Afternoon, here are the solutions to the homework questions. I realised that some of you had some problems, so I thought making a video solution would be helpful. I think almost everyone can get something out of these videos because almost everyone had something they didn't quite do or they needed a little bit of hints on some of the questions. So here is the first question. We want to find ADC. Now, ADC, the triangle, is isosceles. So you can use that fact to work out that ADC must be 130 degrees. And the reason is because ADC is isosceles. You might have written some sort of calculation like 118 minus 25 times 2 is the angle ADC, which is 180 minus 50, which is 130. Okay, so that would have been the answer to that question. Next, angle ABC. Now this is one of the rules we talked about in lessons. So angle ABC is 90 degrees, and the reason is because angles in a semicircle are always 90 degrees. This is not what George Beer said. George Beer said ABC is 90 degrees because it is a right angle. That's not correct. You have to write this definition because angles in a semicircle are always 90 degrees. That's the simplest way you can state it, so don't faff about with your words, just write that down. Next, BAD. BAD is that angle there. So let's fill out some of the angles we know. We know that this angle is 130. If we know that angle is 130, then we know that this angle is 50. We also know that this is a right angle. So we can look at the triangle BAD or ABD. We can look at that small triangle there and work out the missing angle to be 40 degrees because angles in a triangle sum to 180 degrees. Okay, the next part. We are told that DC is equal to 5 centimeters and AD, that should be BD, hold on. And we're back and BD is equal to 3 centimeters. And the question says find the area of ADC. So let's put those lengths in. DC is 5 and BD is 3. We are trying to work out the area of that yellow shaded region there. So lots of people kind of started this question. They got something nice and then they stopped, but they never quite answered the whole question. The question wants the area of the yellow region, so do answer the question that's being asked. Let's fill out some other things we know. If we know that that top side is 5, then we also know that this one is 5 because it's an isosceles triangle. Okay, we can work out the length of this side using Pythagoras. We have a triangle where one side is 3, the hypotenuse is 5, and this is the missing side. So we could say that 5 squared, the hypotenuse, is equal to 3 squared, plus, let's call this A squared. So rearranging, we get 5 squared minus 3 squared is A squared. This is 25 minus 9, which is 16. So A squared is 16. So A then must be 4. Great. So what might we do now? We could work out the area of that blue region there. We have the base is 3 and the height is 4. So the area of that triangle will be the base times the height, 3 times 4 divided by 2. Okay? Next, well, I'm going to go back a second. We could just work out the area of this whole triangle here, this triangle in green. Okay, so this green area here, we know the base and the height of this triangle again. The base is going to be 8, it's that 3 plus the 5, and the height is 4, so it's going to be 8 times 4 divided by 2, making the area of that big green triangle 16 centimeters squared. So, to work out the area of the yellow region, well, if I'm just move the area, this green area for a second. Oh, hold on. So that yellow region we could think about as the green region, take away the blue region. And that would be the yellow region. So we know the green region is 16, the blue region is 6, so that means the yellow region must be 10. A couple of people, when they answered this question, they said, well, we know that it's a triangle that's 5 by 5, so they just decided that they could do base times height divided by 2. This is not correct, because this 5 here, this is not the perpendicular height. This is not the height of the triangle, which means that you can't answer this question by doing 5 times 5 divided by 2. You have to know the perpendicular height. We could do this with the right-angled triangles, because when you have a right-angled triangle, the height is the perpendicular height. Okay, I'm going to stop this video here and answer the second question in a separate video.